Depict the electron configuration for phosphorus using an orbital box diagram and noble gas notation. So give one possible set of 4 quantum numbers for each of the electrons beyond those of the preceding noble gas. So let's first do the less fun long-handed version that they asked for. So for phosphorus, it's not too far away, which is good. But if we wanted to get it, it's the 1s, 2s, 2p, 3s, 3p, 3d, okay? And then 4s, 4p, 4d, 4f. But for phosphorus, we're kind of only going to, whoops, sorry, I skipped ahead. Definitely didn't even write the question down. Not the best habit. But nonetheless, electron configuration of phosphorus and orbital box notation as well. Okay, and give possible set of 4 quantum numbers. So with all that being said, for those preceding the noble gas, okay, with all that being said, so phosphorus, we can see here that it's the 15th element, okay, so it kind of blasts right through the first shell. So hydrogen is done, and helium, so we have 1s2. And then for the 2s row, it's past lithium and beryllium, so we have 2s2. And then it's past neon, which is now the 2p6, okay, and it blows right past through sodium and magnesium, which means it fills the 3s2 as well. And then it also goes past aluminum and silicon, and then there's phosphorus, so it's right here. So that'd be 3p3. That is what phosphorus ends up as. And if we were to do the noble gas notation of phosphorus, we start with the previous noble gas, which is neon, okay, and then we have 3s2, 3p3, okay, and then they're asking for the orbital box notation as well. I'm not going to do the full one because it gets really tiresome. Fine, you've convinced me. So with that, we're going to actually draw it out. And this is the orbital box notation, okay? So we have 1s2 because there's 2 electrons there. 2s, oh, I forgot something. This, but I don't like it. This is the 1s. Actually, I have the ones on the side, so this is the s. This is the p. Whoops. Rush that one. S, S, S. And these are the p rows. And you'll see why based on the 6. Okay, so we have 2s2, 2p6. Don't be deceived at how I'm drawing them. They get filled a little bit differently. Okay, and then we have 3s2 completed, and then 3p3, and it goes like this, that, and that, because it fills its first electrons in each subshell first. Okay, it doesn't kind of bunch it together. So with that being said, the noble gas notation for this, okay, think of it as we start with the 3. We just say that it starts with neon, okay, and then we have our boxes again. Alright, and then, shoot, forgot one more box, haha. And then we have the S, that's done. Then we have the 3p3. Okay, so now with that being said, this is our 3s, 3p, 3p, P. So we've successfully drawn every type of form for shorthand and the longhand form. So now they're asking us for the possible quantum numbers for it. So as a review, there's 4 quantum numbers, okay, as I mentioned. We have the N, we have the L, ML, and MS, okay? So N tells you what shell we're on, and they specifically ask for the quantum numbers in the valence shell, so past neon, okay? So as you notice here, all we're dealing with, which is N, is 3. The N always has to equal 3, specifically for phosphorus when it's past its, when it's in its valence shell, because of the fact that we've gone past all the other orbitals. The first, second orbital, we've passed through them, and we're on the 3rd orbital. The L, okay, for this one, it'd be easy to break this down this way, okay? So L, when L is 0, that means that we're in the S shell. L is 1, we're in the P shell. L is equal to 2, we're in the D shell. And L is equal to 3, we're in the F. Considering that we're only dealing with S and P's, we're only going to be dealing with zeros and ones. So L can be 0 or 1, okay? ML is a possible is a positive and negative values of your L. So if you look at your L, okay, we can have either 0, okay, for the 0, and then for the 1 we can either have -1, 0, or 1, okay? These are going to be the different MLs, and you'll notice that it actually match perfectly with your S and the P rows. We have the S for the 0, and the P is -1, 0, and 1, okay? And the MS just tells you what type of spin it has, which is going to be -half or 1/2, okay? That's the only 2 choices it can be, alright? So now they just want us to give us, they want us to give just one example of a possible set of quantum numbers, okay? Let's say we chose this one, okay? This one, theoretically, if we're following this, okay, if this was the -1, this was the 0, and this was the 1, okay, this would be 3, 1, okay, 0, because it's in the middle, in the P orbital, and then it can only be 1/2 because only half of them are there. Whoops, sorry. I believe you start with a negative spin. It can only be -half because each one has a negative spin there. I may be wrong about the spin part. I don't remember which spin you start with. Okay, so you start with a positive spin when it's pointing up, which makes sense because it's pointing up. So it'll be +1/2, okay? And with that being said, then that means anything in your P shell, so anything that has the 1, you would have a +1/2 because that's the only one available. If you're dealing with something with in your S shell, it would still be 3, but now this will be 0, and then this would also be 0. There's only one of them, and then you could choose either a +1/2 or a -1/2. A -1/2 in this case will be referring to this one right here. Alright, so these are 2 possible very real combinations for the electron in phosphorus, okay? So as we see, they got the same answer we did when it comes to right now it's full form. And then we have 3s2, 3p3, perfect. We have this, and they actually were nice enough to list off every single combination. So as you see here, actually, we have 300 +1/2 and 300 -1/2 we did here. Then we have 3-1 +1. Okay. Oh, I get. Oh, interesting. Well, yeah. I guess it doesn't really matter which one, as long as you're keeping track of which one's your positive, which one's negative. But to keep it constant, I'll just follow them. So this will be +1. This is -1. I guess the pluses always come before the minuses. This is a good rule of thumb. So you have 3, 1, 1, plus 1/2, and 3, 1, 0. So that's what we got here. And then plus 1/2, and then 3, 1, minus 1, plus 1/2 as well. So this is correct. Okay. So that is all you need to know about electrical configuration and how to actually